This is your reality check.
Welcome to The Reality Check, the weekly Canadian show that explores a wide range of controversies and curiosities using science and critical thinking. Today is July 4th, 2020. Happy belated Canada Day to our Canadian checkers, and happy Independence Day to our American listeners. I'm producer Pat, and it's just me as we continue with our coronavirus lockdown format. We have two interesting segments for you today. Darren is going to talk to us about modern slavery. But first, Adam looks into recent headlines about there being 36 alien civilizations in the Milky Way. 36 is a very specific number. I hope everyone out there is staying safe in these strange times, and we will talk to you soon.
What's up, cuboids? Have you seen the good news? There are 36 alien civilizations in our galaxy, or, depending on the headline, there are at least 36 alien civilizations, or something of the sort. This has been widely reported on, though many articles don't give a ton of detail into how the scientists in question found the number, but you can be sure they used a lot of math. So what's going on here? I suppose before we dig into this, we should talk a bit about the Drake equation. Now, Pat talked about the Drake equation on episode 435 of our podcast back in 2017. And this equation basically tries to calculate the number of technologically advanced alien civilizations using a formula where that number, n, is the product of the following values. R star, it's the rate at which stars are created in our galaxy. Fp, the fraction of stars around which planets will form. Ne, the number of planets which could support life around every star which has planets. Fl, the fraction of planets which could develop life which will develop life. Fi, the fraction of planets which develop life which would develop intelligent life. Fc, the fraction of intelligent life which would develop a civilization which could communicate. And finally, L, the length of time during which such a civilization would send radio signals into space. Now, the problem here is that we can use science to determine a few of these, but most of them we have no idea of since there is only one instance of a planet which has developed life which we can use as a reference, and that's our own. And due to the anthropic principle, we are only able to postulate our own existence because we are here and wouldn't be around to ask the question if we weren't. We don't know how rare this is. Frank Drake's original estimates were between 20 and 50 million intelligent civilizations right now. Other estimates had it being much lower. There is, of course, new stuff to consider since this equation was first postulated. We now know for a fact that there are planets around other stars, something which was suspected but not confirmed at the time. We can also tell about some planets being more or less Earth-like, which we suspect makes them more or less likely to be habitable. Stuart Robbins was once on our show to talk about how our magnetic field contributes to the habitability of the Earth, a factor which one could also consider when gauging the likelihood of the number of other civilizations. There are many other factors to consider as what could be part of a habitable zone. So what's this new thing all about? Now, the findings come from a new paper in the Astrophysical Journal titled The Astrobiological Copernican Weak and Strong Limits for Intelligent Life by Tom Westby and Christopher J. Consolis of the School of Physics and Astronomy at the University of Nottingham, UK. The research attempts to calculate the number of CETI, C-E-T-I, or communicating extraterrestrial intelligent civilizations. So this is looking for the same number as the Drake equation attempted to calculate. They make some assumptions. One is that life on our planet took some 5 billion years to develop. It's actually 4.54 plus or minus 0.05 billion years. The age of our solar system being 4.568 billion years. Now, this is a key part of the analysis, and that's using the age of a star as an approximation. Now, this is a key part of the analysis, and that's using the age of a star of an approximation of the likelihood that there might be intelligent life. The assumption is that life will form on a planet in the habitable zone around a suitable star within our galaxy over a similar amount of time as it did on Earth. The weak astrobiological Copernican scenario supposes that intelligent life will occur after 5 billion years, but can form any time after 5 billion years. The medium scenario states that intelligent life will form between 4 and 6 billion years, and the strong astrobiological Copernican scenario states that intelligent life will form between 4.5 billion and 5.5 billion years. Now, there isn't really a strong argument for which, if any, of these scenarios is actually true. We frankly don't know. This is an assumption, and the writers of this paper freely admit this. So the paper seeks to calculate how many stars are in that range in our galaxy. The paper acknowledges the Drake equation and simplifies it to a new equation, the Chetty equation. Using a basic assumption that an Earth-like planet in the habitable zone which exists for a certain amount of time will develop intelligent life. By the paper's own admission, it completely ignores the Drake equation variables, FL, that's the fraction of planets that could host life that develop life, and FC, the fraction of planets that develop intelligent life that would release signals that could be detected. Now, the rationale is the principle of mediocrity. They state that there is no reason to assume that the Earth should be treated as a special case. This is argued to be in line with the Copernican principle, basically saying that the Earth does not have some privileged place in the universe. Well, that's cool, but this is a really huge assumption. The researchers do seem to understand this, but they consider this a sort of upper limit, and they don't really have any alternative way to look at it. So, the new equation is this. They're looking for n, once again, the number of intelligent communicating civilizations, and that is the product of the following. N star, the total number of stars in our galaxy. FL, the fraction of stars that are older than 5 billion years. FSP, the fraction of stars which host a suitable planet in a habitable zone which could support life. And L, the average lifetime of an advanced civilization. Now, this is divided by tau prime. That's the average amount of time in which life could exist, which is basically the age of a star in billions of years minus that 5 billion number. What this equation does differently than the Drake equation is that it considers the age of stars in the universe rather than simply using the rate of star formation. So the Drake equation assumes an equal distribution of intelligent civilizations over time. But this equation basically says the older a galaxy is going to be and the older the stars in that galaxy are going to be, there are more of those that could potentially support life. And that makes sense. Again, we have a value L, which is the length of time that a communicating civilization would continue to communicate. They set this as a lower limit of 100 years, because that's what we do. Does this seem like a good assumption? While I would assume that on average an intelligent civilization may last longer, we don't really know this. We may have survived 100 years beyond our first communicating with radio signals by sheer luck, somehow escaping death by nuclear war, some sort of bioweapon, or some other method, and only being around to ask the question of how long a civilization might exist, again, because of the anthropic principle. Again, we have no real way to know for sure. If we destroyed ourselves 20 years after first sending radio signals into space, we wouldn't be here to ask the question. So next, there's a lot of math to consider the number of stars older than 5 billion years. I won't get into the specifics, but one important consideration is that over 90% of the stars which fit the criteria are low-mass M-type dwarf stars, which is why many articles mention that the closest intelligent alien civilization is likely to be around such a star, because most civilizations, they would say, are going to be around such stars. Now, it's worth considering that most stars that have formed in the galaxy are still around today. The number of stars which are older than 5 billion years is estimated to be 97% of the total of stars in our galaxy, meaning, by the assumption the researchers have made, most stars in the Milky Way have been around long enough to develop life as we have on Earth. But this isn't the only factor that they're considering. Our solar system formed late in the history of the galaxy compared to most. The average age of stars which are older than 5 billion years is 9.8 billion years, meaning that tau prime, the time during which life could evolve, is 4.8 billion years on average. Quite a long amount of time. There's then some math on the fraction of stars with appropriate metallicity to be suitable to form life. The idea is that life on Earth evolved in a metal-rich environment, so perhaps this is a prerequisite for life everywhere. That's another assumption. We don't really know. Then there's the calculation of the subset of planets that are in the habitable zone. So using our solar system as a reference, if we were much closer or much further from the sun, life as we know it could not survive. So the assumption is that since we couldn't survive, life would never have existed on our planet in those situations. Now, I won't get into the specific math on this, but again, this is an assumption. Maybe there's a different kind of life that could survive in a much hotter or a much colder environment. We really don't know. We don't have a lot of examples. So a lot of these values are a bit of a range, and there are a lot of unknowns. This simplifies the equation to be n, the number of Chetty, as a product of the value k times L. That's the lifetime of a civilization which is unknown. So we put that at 100 to be conservative, and we get a few values because we don't have specific answers to a lot of the values we're looking for. There are also a lot of calculations related to the distance to the closest civilization, and I won't get into any of this, but it all works off of the same assumptions, so the analysis seems sound given those assumptions would be correct. Now, there are a lot of possible values given for the weak, moderate, and strong principle. The most limited one is the strong, assuming the Ceti can only form during a limited range of the stellar age between 4.5 billion and 5.5 billion years. This itself gives three ranges based on three potential minimum stellar metallicity values, the lowest of which is 36, plus 175, or minus 32. This is a fancy way of saying between 4 and 211. The results also calculated that the closest such civilization would be 17,000 light years away, plus 33,600, or minus 10,000. So that range would be 7,000 to 56,000. Now, if they use the weak scenario with the highest estimate, we're looking instead at 928 plus 1,980 or minus 818. This in turn would have the closest civilization at 3,320 light years away, plus 6,300 or minus 1,400. So that range would be something like 1,880 to 9,620. So that's a much different number, maybe a more interesting headline that makes the galaxy sound teeming with life. But 100 years as a lifetime seems very low to me. What about a huge number? So if we instead assume that a Ceti could live on average millions of years, we would expect the closest ones to be between 20 and 300 light years away. Pretty close, all things considered. If we plug in 2,000 years instead, this gives us 400 to 7,000 light years. So we see that this number can vary quite a bit depending on unknowns like the potential age of a civilization before it goes extinct. Now, it's difficult for me to evaluate the legitimacy of the math used in the paper. It's a bit beyond me, and I suspect it would take someone like Dr. Stuart Robbins to understand this enough to tell me if there are any flaws. Generally, it seems to make sense, though some of the values could certainly be adjusted as our understanding of stars in our galaxy improve. So how could we disprove something like this? Because if it's not falsifiable, it's not really science. Can we find a planet in a habitable zone that's of a certain age that doesn't have a Ceti? Well, Mars. The habitable zone in the paper is listed as being conservatively estimated as being between 0.95 AU, where an AU is the distance of our Earth from the Sun, and 1.67 AU. Mars is generally between 1.382 and 1.666 AU as its distance from the Sun. Its age may not be over 5 billion years, but it's in the medium and strong ranges, what with its star being the actual one example we have of a star which has planets around it with life. Our planet, Earth. Now, we can hardly say that the planet hasn't had time to produce a Ceti, as life on Earth has existed for billions of years, and we have yet to find evidence of anything closely resembling what we have here on Earth on Mars. There are still people that argue whether or not there could be life on Mars, but it's clear that if there is life on Mars, it's not like what we have. So it seems like a bit of an oversight. There may have been some other criteria in the paper that would have ruled out Mars, but it wasn't something I picked up on when I read the study. Now, I find all of this to be useful, and it's nice to see some numbers here because, like with the Drake equation, it can tell us that our galaxy is huge and the sheer number of stars suggests that if life is at all likely to develop when the conditions are right, then we should expect that there could be quite a bit of it. But as the researchers freely admit, there are a lot of assumptions that we can't really know the definitive answer to. We certainly can't state that an Earth-like planet will absolutely develop a Ceti under the right circumstances, as we have an example of one that didn't do this right in our own backyard. We also don't have any evidence that life originated more than once on Earth. Had this happened, this would suggest that abiogenesis is common once the conditions are correct. But this is a whole other issue. It's possible that this did happen more than once, but then once life was developed enough and other competing life was still too young to develop any sort of fossil evidence, one type of life just outcompeted the other and never gave the other a chance to have a foothold. We really don't know. It's hard to tell. I've also got my own issue with this concept of communication. While I understand that many civilizations may very well destroy themselves, as ours might, even if only a fraction of civilizations make it beyond that, they could potentially thrive for billions of years if they make it past a certain technological level, or if the AI that they create makes it past a certain technological level. So it's not a matter of listening for radio signals in space, most of which are probably too far away for SETI to be able to detect them, but such a civilization that lasted for billions of years could potentially spread across the entire galaxy in time with interstellar travel. The Fermi paradox asks why we haven't seen signs of life, but I don't think this should be limited to why we haven't heard some radio signals. but why hasn't every corner of our galaxy been touched by a vast interstellar civilization? I, for one, am just happy that our solar system hasn't been consumed by self-replicating von Neumann probes. Maybe by the anthropic principle, our corner of the galaxy happened to be overlooked by the probes. Otherwise, we wouldn't be around to wonder why we live this long. There's other issues here. There's the dark forest idea, and there's all sorts of things. I have a lot of thoughts on all of this, but it's not really so relevant to this particular study, so I'll save that maybe for another segment. There's nothing special about this very specific number of 36 civilizations. It's unlikely that the number of Ceti is exactly 36. This result, while interesting, is based on many assumptions which we must take at face value. The results give us interesting and promising ideas about a potential upper limit for values of intelligent alien civilizations in our galaxy. Let's hope that the age of our Ceti is long enough that we might have a chance to communicate with another, and that such an exchange doesn't itself result in our own annihilation. Peace out, cuboids.
It's been about 8 years since I did a segment on slavery, way back in episode 194, so I thought it was time for an update. In that previous segment, I talked about how slavery occurred in nearly every country, and even within countries. I also spoke of slavery in our current times, and it is this modern slavery that I shall discuss today. I will talk to you about what modern slavery is, how many people are enslaved, where slavery occurs, and what you can do about it. My main sources are antislavery.org, Kevin Bale's organization Free the Slaves. It was his book Disposable People that I mentioned 8 years ago, the International Labor Organization, and Wikipedia's Slavery in the 21st Century page, all in the show notes at trcpodcast.com. So let's try to situate ourselves in this horror. What is slavery? This isn't as straightforward to define as you may think, and there are at least minor differences of opinion. The broad point is that one person has control over another person for exploitative purposes, often related to forced labor. Free the Slaves says, quote, "Slavery is the holding of people at a workplace through force, fraud, or coercion for the purposes of sexual exploitation or forced labor so that the slaveholder can extract profit." Free the Slaves uses a sociological definition to describe slavery, a person who is forced to work without pay under threat of violence who cannot walk away. End quote. Anti-slavery says, "Modern slavery is exploitative labor that places one person in the control of another." And then they elaborate a bit further. Quote, "Slavery exists on a spectrum of exploitation, and sometimes it is hard to establish a clear line to define what constitutes slavery. However, if a person is forced to carry out work for which they didn't offer themselves voluntarily, and they are not free to leave, it is a case of slavery. For example, quote, someone is in slavery if they are forced to work through mental or physical threat, owned or controlled by an employer, this is in quotes, usually through mental or physical abuse or the threat of abuse, dehumanized, treated as a commodity or bought and sold as property, physically constrained, or has restrictions placed on his or her movement." Anti-slavery elaborates on different forms of slavery, such as forced labor and bonded labor. Here there's the idea that you've entered into some sort of contract, but then it turns out you cannot leave the property where you work, or you just cannot leave at all. Human trafficking. This is a broad term for almost any international movement of people against their will, which then, once they get to a location, is usually the actual slavery. And it's often linked to ideas of sex trafficking, but human trafficking more broadly it's almost the process by which slavery is moving about before it actually happens. Descent-based slavery. Your parents were in some sort of debt bondage, and now you, as the child, are also. The worst forms of child labor, again with the forced component, slavery in supply chains, forced and early marriage, and the exploitation of migrant workers in conditions amounting to slavery. So notice that Free the Slaves is mainly focused on exploiting labor, but in other materials they do mention forced or servile marriage and even child soldiers. For child marriages, you're not really supposed to imagine two 16-year-olds getting married by choice. It is more the forced aspect of it. Perhaps a daughter is sold as a wife to pay a debt to someone. Anti-slavery breaks it down as follows. Quote, "Child marriage can be referred to as slavery if one or more of the following elements are present. If the child has not genuinely given their free and informed consent to enter the marriage, if the child is subject to control and a sense of ownership in the marriage itself, particularly through abuse and threats, and is exploited by being forced to undertake domestic chores within the marital home or labor outside it, and or engage in non-consensual sexual relations, if the child cannot realistically leave or end the marriage, leading potentially to a lifetime of slavery. Being a child soldier is its own sorts of horrible thing, but the power and control makes it very difficult to escape that life, and you end up actually harming many people while being a captive. I just want to quickly mention that. A last comment about what slavery is. To some, government conscription counts as slavery. You are forced into military service, and then when in the military service, you may be forced to engage in different labor activities to build different things or engage in projects, and you cannot leave the military, a threat of death. It is possible that there are a couple million people in such a situation in North Korea. In the next part of this segment, I want to discuss how many people are in contemporary or modern slavery. Given the range of activities that I mentioned, and the fact that it's hard to verify much of this information, if it were, it'd be easier to stop, it is hard to get precise estimates on the numbers. Some estimates are in the range of 20 million, but others go as high as 46 million. Many seem to use the International Labour Organization statistics. I've decided to round these numbers mainly so it is easier for you to listen to, and minorly because of uncertainty. So, this is a quote from the ILO. At any given time, this was in 2016, an estimated 40 million people are in modern slavery. This includes 25 million in forced labor and about 15 million in forced marriage. It means there are 5 victims of modern slavery for every 1,000 people in the world. That's about 0.5%. 1 in 4 victims of modern slavery are children. Out of the 25 million people in forced labor, 16 million are exploited in the private sector, such as domestic work, construction, or agriculture. 5 million people are forced into sexual exploitation, and 4 million into forced labor imposed by state authorities. 70% are women and girls. They are the main targets for child marriage and sex trafficking, and a lot of the exploited labor. Where does slavery occur? Unfortunately, the answer is pretty much every country on Earth. Of course, this is not to the same degree, and there are huge disparities. According to the Global Slavery Index, the countries with the highest absolute number of people in modern slavery are India, China, Pakistan, Bangladesh, and Uzbekistan. Of course, India and China being the 2 most populous countries on Earth, that seems to make some sense. But slavery also exists in the West. The top 10 countries taking the least action to respond to modern slavery, and this is from Walk Free Foundation, are North Korea, Eritrea, Libya, Iran, Equatorial Guinea, Burundi, Democratic Republic of the Congo, Russia, and Somalia. Now, Mauritania isn't on that list, but in Mauritania, 2% of the population is in slavery, and this number could be as high as 20%. Absolutely horrible. So slavery really is an international thing. It occurs in many different places, mainly in East Asia, Southeast Asia, and parts of Africa, but it is an international issue, especially when you consider forced domestic labor and sexual trafficking. So it's estimated there may be hundreds of thousands of cases in the United States alone. Now, some of you may be wondering, well, what causes slavery? Vulnerability is the main issue, which of course is heavily linked with poverty. Just because you're in poverty doesn't mean you're going to be enslaved, but it does mean you're more likely to be vulnerable, which makes you more likely to be enslaved. Free the Slave says the main variables are a lack of awareness and rights and risks. People don't know that they may have rights and freedoms, such that they can't actually be held until their debt is paid. Absent or weak protective organizations. So in poor communities, there aren't effective institutions that can actually protect people against these sorts of things. And absence of critical services. So sometimes you turn to exploitative money lenders because you really just need money, and then that gets you into a deeper and deeper hole. Inadequate legal protection. Very poor people are least likely to be protected by the law, unfortunately. And also survivor vulnerability. Once someone who has experienced something like slavery, their life is, ruined in various ways, and they become less able to function, quite understandably, and that makes them more likely to be re-enslaved. Well, how can one stop slavery? And this is from Kevin Bale's organization. Quote, "The key to stopping slavery is helping vulnerable communities and people acquire the assets and tools that will overcome their vulnerability. All the Free the Slaves programs begin with contextual research to define the vulnerabilities and pathways leading to slavery and needed interventions. Based on that research, we adopt the following basic strategy. Capacity building. So you're trying to provide training and technical assistance to strengthen local organizations to achieve sustainable solutions, partnering with different organizations. Educating and organizing vulnerable communities. This is where you're trying to help communities understand the rights and the risks of trafficking. For example, they say in the Congo, they're supporting the broadcasting of anti-slavery messages over a network of community radio stations. Increasing access to basic services. Mobilizing communities to advocate for schools, health, and credit. Again, the less people have to rely on outside, we'll say sketchy or deplorable individuals to provide them with basic services, the less vulnerable they will be. Additionally, there's legal protection and liberation. So they advocate for better laws and improved law enforcement, trying to train police and government officials, as well as journalists so that they can better report on slavery, and reducing survivor vulnerability. So trying to target those very at-risk individuals to ensure things that don't happen again. With such a heartbreaking topic, many of you listening probably feel quite troubled about this. As well you should. It is horrible. As I've said in a recent show, I don't know if there's anything worse than being an enslaved person. So you could also donate to the organizations I mentioned, or share their materials, or even share this episode to raise awareness. Finally, for those trying to manage the psychological horror of slavery, I'll give you some numerical framing that I have given myself for years. 40 million in slavery is equivalent to 0.5% of the global population. Just a staggering number. But I suggest you think in absolute numbers to get motivated to do something about it, but think in percentages to be able to sleep at night. Think better to act better.
For show notes or to discuss this episode, visit our Facebook page and website at trcpodcast.com. For general inquiries or to send a topic or parody suggestion, email info@trcpodcast.com. Help support the show by leaving a review on iTunes and liking us on Facebook. Follow us on Twitter at @TRC_podcast.